Okay, continuous compounding. The formula for future value of investment compounded continuous over many periods can be written as the future value is equal to that cash flow, the initial cash flow or investment, multiplied by E, the exponential. That's a 2.71. There's a function on your calculator to the RT. So rate times time. So, so C0 is the initial investment, R is the APR, T is the number of years. Whoops. See, and E. So this is the official definition. The transcendental number approximately equal to 2.718. It goes on. It's like pi or one of those other numbers. It goes on forever. Again, e to the x is a key on your calculator. Simplifications. Perpetuity is a constant stream of cash flows that lasts forever. Example of perpetuity in the United States would be preferred stock. Most preferred stock is issued and is never called. There are some exceptions to that, but the growing perpetuity is a stream of cash flows that grows at a constant rate forever, and then an annuity is a stream of constant cash flows that lasts for a fixed number of period of times. The example of a backwards annuity, but your car payment, your house payments, those sorts of things are annuity payments. They're streams of constant payments. Then there are also growing annuities, streams of cash flow that grow at a constant rate for a fixed number of periods. A sort of an example of that would be a retirement benefit. Most of the time, retirement benefits are Social Security and so forth. They're indexed at the consumer price index or some similar number, so it's not necessarily a constant rate. So, perpetuity. So, constant stream of cash flow goes on forever. So, the present value is just equal to all those cash flows divided by the respective interest rate, the number of periods. We can simplify this is to simply the cash flow, since that cash flow doesn't change, divided by the required rate of return. Example of perpetuity. This example of British Consul, it promises to pay £15 a year every year forever. If the interest rate is 10%, again we're going to receive £15 forever. To calculate the present value of that, it would simply be the £15 divided by the required rate of return, 0.1, 10%, and that would give us £150. A growing perpetuity. So, see the growing stream of cash flow that lasts forever. So, what we're talking about, the example here would be a constant growth stock, a stock that grows at the same rate every year in perpetuity. So, if we're calculating it a long way, it would look like this. However, we can simplify this. The present value is equal to the cash flow. And in this case, it's actually important to note that this C is the cash flow in the next period divided by the required rate of return minus the growth rate. So very important to remember that we need that in order to calculate a present value in the current period, we need a cash flow from the next period. so or period one. So growing perpetuity example. So we've got a dividend expected of $1.30 next year, and they're expected to grow at 5% forever. So the 10% discount rate. So what is the value of this promised dividend stream? The present value is equal to the $1.30 dividend next year divided by our 10% required rate of return minus that growth rate. So 0.10 minus 0.05, that gives us the value of that stock is $26. So one thing to note, if this $1.30 was this year's dividend, we would, as opposed to next year's or the current year's dividend, we would grow this at 5%. So we'd multiply it by 1.05. So you need to pay attention on the problems like these and determine whether this is what I would call D0 or the current year's dividend, or the D1, which would be the upcoming year's dividend. Annuity, constant stream of cash flows with a fixed maturity. So we'd have cash flows out to some period T. So we could present value those by hand. We can also use our calculator. So, but there is a simplification. The present value is equal to the cash flow divided by the required rate of return, multiplied by 1 minus 1 divided by 1 plus the required rate of return to the power of the number of periods. Example, so you can afford $400 a month monthly car payment. How much can you afford if interest rates are 7% on a 36-month loan? So again, we're calculating the present value of the $400 for 36 months. So it's going to look like this. We take our payment, the $400, we divide it by the interest rate, 7%, 0.07, but we have to divide by 12 to make that into a monthly rate. And then we multiply that by 1 minus 1 divided by 1 plus the interest rate divided by 12 to the 36th power. So if that were the case, we could afford a $12,954.59 car loan.